Hi everyone. I'm Parag Ahire. I will be talking about vibe-coded chatbot app. So vibe coding, as most of you know by now, was supposed to be a meme based on a tweet by Andre Karpathy not too long ago in February 2025, and it kind of went mainstream immediately after. It was also popularized after a keynote talk by Andre in San Francisco at an AI school startup. So what is vibe coding? Now, traditionally, software development as we know it has always involved the design, code, test, and iterate cycle, right? That's how all of software 1.0, as Andre Karpathy calls it, has been followed. But with software 2.0 and now what he calls the software 3.0, which is what we are talking, we are extensively using AI assistants to create the applications and write the code for us, right? So it's a mindset change, and humans are collaborating with AI assistants, and the role of a human is now changing from a programmer to more like a conductor in an orchestra, right? So basically, the programmer or the developer gives an idea, he acts like an architect, he reviews the code generated by the AI assistant, puts it to test, and continuously iterates until the desired functionality is achieved, right? So that's what is the new development style, which has fortunately or unfortunately become mainstream now, right? What are the benefits of vibe coding? It enables rapid prototyping. One can generate a MVP in hours, not weeks. And even people outside of the programming world can now do that, right? We see now product managers kind of create their own prototypes for evaluation purposes, just to see if their idea makes sense or gels or not. So it's not just limited to those who have been in the programming world, right? We are able to get started with unfamiliar languages and frameworks, as we will just see going ahead. And as I mentioned previously, every programmer is now an architect and a reviewer. It's more of that role than the traditional think and write the code aspect. So why did I start that, right? Obviously, I had seen this video from Karpathy on Software 3.0, where he made a mention of vibe coding. I always had an interest in developing AI agents using LLMs, RAG, and other kind of techniques. I wanted to particularly focus on using an LLM with RAG and a web search. And then I had to choose some kind of framework to do that, because writing this from scratch is not that easy and not for everybody, right? So I wanted to see if I can develop something in an unfamiliar language using a brand new framework. And then obviously, I had to pick an area, right? And that's where my interest in cricket comes in. I don't know if the audience here is familiar with cricket or interested in cricket, but that's me. Obviously, I wanted the chatbot to be limited to a particular area. So obviously, scope had to be limited. So there's a IPL league. It's a premier league in cricket, and that had just concluded in May, right? So obviously, the LLM that I used does not have knowledge about what happened in that event or in that league. So it was a perfect topic to select. And then I wanted to see if I can get some question answers from it, with primary focus being on using RAG to augment the search capabilities of an LLM that had knowledge from the past. It won't. That's very new.
I asked him about the Asia Cup results.
Yeah, that was like 2 weeks back. That's very new. Okay, so going in, I had an architecture in mind. So obviously, I've color coded this for simplicity. So what you see in light blue is the external world, right? In green are tools that have been made available to this agent. I call the agent the cricket statistics agent on the left. And obviously, we need a vector database for achieving the RAG functionality, where the embeddings would be stored. So I chose ChromaDB. More about that in upcoming slides. But I had to fetch data for these games, and I identified multiple sources of that information. And that's what the cricket statistics fetch tool does. It fetches information for these games. And those embeddings are then stored into the ChromaDB. Once that is done, we need a search tool. So that's where the cricket embedding search tool comes in. That allows us to kind of search for information that is not available to the LLM. I went with Google Gemini 2.0 Flash, a basic one that fits my need. And I also wanted this to have certain guardrails. So I chose the moderation tool and the prompt scrubber tool. More on that later. And obviously for information that is not available or not searchable through the RAG-based search, we need access to the web search. So that's where the web search tool comes in. Okay, so what tools did I use, right? So obviously we all know about Cursor, which is an AI-powered code editor. And I came across this framework called Master.ai, which is an AI agent framework. It is TypeScript-based. And these folks have made it very simple to kind of develop your agents. And they have a lot of functionality, and we'll see some of that going ahead. ChromaDB, as I said, is my chosen AI native vector database. And then there is Exa, which is a real-time AI search engine that can not only extract structured content, but it can also perform a real-time search as indicated. And Gemini is known for speed and efficiency. Now, just a disclaimer that these are just the tools that I happen to use. This is not a promotion or endorsement of any of these tools, but they are all good in their own right. I'm in no way affiliated to any of these companies. Now, what was my process? So I started very basic, right? I just started by installing Mastra. I had no idea of how this would all fit together. I just installed Mastra, followed their installation page, and started with their very basic tool. They had a weather tool and an agent, just about 10 lines of code each, right? And obviously I needed Node.js and TypeScript to be installed. And then obviously I needed an environment to develop this in. I moved to Cursor. I also had to set up keys for Exasearch and Gemini and get installed ChromaDB. So once that was done, I first identified all the web pages of interest that will have statistics related to the games, the information about the game, like the match report, the full scorecard, the ball commentary, information about the MVP of that game, and so on and so forth. All those pages were fetched using the tool that I mentioned, which is the Cricket Statistics Fetch tool. And how did I get to that? Again, vibe coding. Just gave the instructions in Cursor to turn that weather tool into a cricket data fetch tool. And obviously there were iterations involved. It started with a very basic one. It was not able to get dynamic content. And I realized that as I went ahead. So it essentially took the HTML and the JSON from those pages without actually extracting textual information for the statistics or whatever is relevant to that game. More on that later, right? And then I added the capabilities of web search by using Exasearch. I added the Cricket embedding search tool, which is actually going to use the embeddings to answer a particular question. And then adding moderation and prompt scrubbing was very easy with what Mestra provides out of the box. And lastly, I just once again transformed that weather agent into Cricket statistics search tool. So basically just change the code and then rename the .ts file to what I want it to be. So I don't know if this is very visible, but this is what the product structure, the project structure that I ended up with. There is something about an agent. There are these tools. And in general, the agent is made aware of what tools it has at its disposal. So it is limited to those tools. And again, I wanted the agent to first do a RAG-based search. And only if the information is not available, go to the web search. So that is what is instructed in the description and the system prompt and things like that. So a lot of this was achieved without me writing a single line of code, right? I mean, literally, I have no familiarity with TypeScript. I've done programming in plenty of other languages, but other than adding the URLs in a list, I literally did not write any line of code. And obviously that's both good and bad. And we'll see some of that later. So now I'll just move it on to some results. Now everybody may not be familiar with the content here, but I'll just walk through it. So on the left top and the right bottom, we have some questions which are not related to the tournament, IPL 2025, right? So promptly, the scrubber just says, hey, these questions are not related to IPL 2025. I won't answer that. And same here, right? There is something to kind of something like a prompt injection, right? So this was also avoided by the scrubber tests. I have other tests that were successful that not all is being demonstrated here. Now, as far as moderation is concerned, I tried to see if it can get any kind of hate speech or harmful content or inappropriate content, and most of the time it was able to prevent any of that talk, right? Now, yeah, the one on the right is a real incident that has happened after that tournament. There was actually a stampede that happened when the victorious team went on to celebrate in their hometown, right? So the police force had not expected so many people, and there were, I don't know how many, but tons of people who were there, and it actually caused a stampede there. So again, the tool was able to kind of avoid or dodge that particular question. Now on to actual results, right? So here is an example of the search being limited to the cricket embedding search tool. There are a couple of questions where it got the right answer. And again, as Andre said, it's about just about works, right? It's not perfect. And I'll talk more about that later. So again, I was able to get information of a particular game in that tournament. Now about web search. So this is a 14-year-old kid who made his debut in this tournament. I wanted to know, hey, what were his performances in all the matches, right? So the person played 7 matches and scored these many runs, and so on and so forth. On the right, again, is information about a certain event, which is a hat trick. For those of you who don't know, it's about getting three individuals out on 3 successive deliveries. And then lastly, a question about particular individuals who had certain number of wickets. And at times, the information is not available locally. A RAG search is not successful. And in those cases, I saw it go out to the web search tool and get those details, right? So here's a list of all the batsmen who scored more than 100 in a single game. So I wrote up a Medium article on this, and anyone interested in looking at the details can read it up. But I then want to move on to what are the principles of building AI agents. So these people at Maestra have published this book. It's available as a free PDF. For a while, they were also giving up this big book for free. But I just listed a few of the principles that kind of gelled with me. So obviously, someone like me who is starting experiments, it's always good to start with a hosted cloud API provider. Never forget the importance of few-shot prompting for more precise control of output. And provide as much details as one can in the tool definition and the system prompt. And when you design certain things, think of all the tools that you're going to need for this agent, and what functionality would each of those require. And it, as mentioned earlier, it is best to define that functionality so that it can be limited to what it is supposed to achieve. Things can go wrong with these agents, right? So it's always good to kind of run experiments in a sandbox environment so that we don't cause any harm locally. And then another taking of this is that coding assistants, they can write code, they can run it, analyze the results, fix errors, and do that iteratively without little or no involvement from someone like me. So yeah, this is the book that they have. And a free PDF is available on their website. So what is working well and what is not working well? I don't think I've reached a stage where the RAG is very effective. It is related to the way that information is stored in the Chroma DB. I think I could improve that, and I've been experimenting with that since when I documented this. So obviously that will improve the efficacy of the results. I have not actually evaluated the relevance and other kind of metrics for such a question answering system. So obviously this is not a production grade application. It was never meant to be. And if everything works well, I am also thinking if I can go beyond just retrieving statistics to kind of creating strategies, runtime, which can be used during the game to say, okay, we have this particular situation, what can the captain do or the fielding team do or the batting team do to get ahead in the game, right? So can we do that? That is something I may have to think about. Mastra, as I said, has a lot of functionality. There are agent flows as well as workflows. They have aspects related to deployment. They have a lot of out-of-the-box scorers, and one can also build custom scorers. So that is something I have started experimenting with. And then obviously, this was an architecture that did not have a client-server MCP kind of architecture. That is something that can be worked on. So what were my lessons from this exercise? Pros and cons. Some of this I've already covered. So obviously it allows one to innovate and express one's creativity. The previous thing is something we talked earlier. And as far as cons are concerned, we have always seen these posts about these applications having security vulnerabilities. The code is not that optimal. Code does bloat over time, and I've experienced that. Plenty of times the functionality morphs beyond what you really wanted it to be. And then if you have not checked in the code frequently, it is very difficult to just go back. This can add technical debt. And then obviously we have all seen those posts where there is a position for someone who can clean up the code that was created by vibe coding. There is actually positions of that kind on ads on LinkedIn today, right? Always build in steps. Do one piece of discrete functionality at a time. And towards that, have limited conversations. Don't keep them too long. If doing this in a commercial setting, always review the code and correct the code where necessary. Obviously, one has to be familiar with the language to be able to do that. And then just look out for code bloat. The success of the vibe coding can be improved based on refining the prompts for a specific task. So definitely just keep an eye on that. And then obviously, I realize that this is not a fully functional production grade application. There's a lot of room for improvement. The first in mind is the efficacy of the RAG-based search. So that's the prime thing for me. So yeah, this is just that tweet from Karpathy, and those circles in red are the ones that I experienced. So not denying any of that, right? And then this is the video that on Software 2.0. Those who have read blogs on Software 2.0 and the videos associated with it will definitely enjoy this one on Software 3.0. This is somewhat recent from June of this year. Yeah, so just about me, I have a background in software engineering and have held different positions from a programmer to analyst, architect, software development manager. Recently, I'm into data science and machine learning. So I consider myself a data scientist by education, although not much as practice, and also engineering manager by education. So currently I work with a company that is into fleet safety management. They kind of develop cameras for fleet safety and fleet maintenance or fleet management. And the role currently I have is of the program manager. So I've got experience in program management also. Yeah, I'm open for questions.
So my question is, yeah, is it better? Yeah, when on the website, for example, crickinfo.com, it gives live scores. So you can do an event-driven mechanism through Lambda and update the RAG.
Right.
So the problem never occurs. The moment, I mean, it's kind of already solved problem. So Are you thinking of in those terms, or I'm a little confused?
No, I was not targeting any
Scores, okay.
live scores, but
Okay.
definitely I can probably think of that being used for strategy, right? Given this match situation,
Mhm.
what can a person on either team do to kind of shift momentum in their favor? So that I think is possible. And again, it will have to have much more knowledge than what I have currently to be able to do that.
Okay. Yeah, you have to incorporate this Lambda function and stuff like that. Perhaps, I don't know, on the Docker desktop, some similar thing through GitHub Actions or something.
Yeah. So right now it's pretty basic, but
Yeah.
obviously if I improve this, there's
Probably,
scope for improvement.
there are certain alternatives, I believe.
Yeah.
Yeah, thanks.
Other questions?
Thank you. That was very informative. I appreciate that. Thank you.
Thanks.
So if somebody had zero knowledge of programming language, let's say they're just in the basement,
Mhm.
could they pull something like this off, or did you use 5% of your coding knowledge?
What helped me is my architecture background and conceiving how software needs to be developed, breaking software app into individual components. So that kind of mindset kind of helps us, because that's, as I said, is the role of an individual in this area. But that said, I know of product managers who have not developed software before, who have started actively using this to ideate, to create demos for their customers, to integrate with external vendors, or to demonstrate how integration with their systems can be done. So there are people who are doing that without having formal programming knowledge even today. So it is possible, but I think some exposure to software concepts, software engineering will kind of help.
And what would be the first step if somebody did not need to learn a programming language? What would you say the first thing they should learn as a base skill set to do this?
I think that's difficult, but yeah, I think, like I said, I just started. I had no knowledge whether I'll be able to do this or not, particularly with a TypeScript language that I've never programmed in. So I would say just dive in, look at some videos, and then follow what they did. So it's possible. And then as we iterate, the capability of that individual will improve, certainly.
Okay. Thank you. Is a copy of the slides available?
Yeah. So I'll post the slides to our GitHub afterwards. There's a request in the chat. Can you show the slide that has the book, the master book?
Yeah, this is the book.
Yeah. And then I'll post in the chat. I think this is the link for that.
I think Ryan had a question.
So when you were doing this, did you feel as it got more complex, the agent was doing worse and worse for you?
Definitely was. If I'm not showing a demo right now, but since I've added extraction of dynamic content and things like that, things are going out of whack. It is now bypassing the Cricket embedding search tool for the most part and going to the web search tool directly, right? So I've seen deterioration in that, and now I'm finding it difficult to get it back to the state where I want it to be, and enforce local search first and then a web-based search.
Have you found any tricks to make that work better? So do you have to like over specify your prompt saying look specifically at this file when you're making changes?
Nothing of that sort, but I periodically ask it to either just give me a way it will achieve it rather than do it. So I would then just read through it and see what it's doing before I allow it to go ahead. That's one. And second thing is always enforce, when you make changes, don't change that concept of first going with the local RAG-based search followed by the web-based search. So at times that has helped.
Thank you.
Other questions?
So given that this was an exploration project, what was the purpose of including the moderation tools? Was it just to understand how those work in practice?
No, I wanted to see the efficacy of those tools and also make sure that it has those aspects built in. So that's pretty important for any kind of application to go from just a proof of concept to kind of adoption. So I wanted to see whether that can be done and how effective it will be.
So were you deploying this out
Uh,
onto the web, or?
No, so this is right now running locally, but Mastra has a cloud deployment aspect, so that is something on my to-do list to try out the deployments. So if I do that, I can ask for feedback from people and see if they can try it out.
Ooh, that's an excellent question from the chat.
Yeah. Which one? Uh, I think speed was of essence. So literally, oh yeah. So what was the hardest trade-off between speed of development and flexibility of the final solution using vibe coding? That's the question. So for me, speed was of essence. Literally, I was in a meetup on a Saturday and went back, started this, and by Sunday evening, I had it done, right? So I wanted to see how fast I can do that. I've seen competitions where somebody has, like Andrew Yang has asked for people to just come in and see what they can develop in the fastest time possible. So I wanted to see if I can give that a try, right? So for me, it was speed, and then the flexibility was at times even lost, but I never looked back, right? So, and it was just to experience how this goes, right? It was not necessarily to build something that can go to production.
Last call for questions. All right. This is an awesome presentation. Can I make one final comment?
Yep.
I haven't done RAG, but everybody I talk to who says they do RAG in a production environment, they do not just do vector search. They do a traditional search and merge it with a vector search. So you can imagine that if you just had games, you could just do a regular database lookup exactly by indexed by which game, right? And then you don't have to worry about, am I going to get the right? But the RAG does supplement well when you're just looking for semantic content, and it's not going to necessarily be a string match on, whatever.
True. Like I said, I did not have what is the best approach for a certain thing. My thing was, can I get something working with RAG and a web search?
Yep.
So I started with that angle, but definitely point taken.
Yeah, this is an awesome project. I love this presentation. I just wanted to add that for anybody who's listening who's not that familiar with RAG, that like RAG is very useful, but in the real world, people do not solely do vector database RAG. They combine it with more traditional VM25 and structured databases.
Yeah. I experienced the fallacy of LLM, right? So at times it has said, hey, this is a future event. It has not happened, so I can't answer this question. So I see that happen. It's not using the RAG and doesn't have knowledge of this event, which is in the future, February or March of 2025, right? So yeah, that does happen.
Awesome. All right. Thank you very much, Parag.
Thanks, everyone.
All right. So next up, Ryan's going to do our monthly ML news. So just 1 second while we switch speakers and get set.
Okay, I dropped the link to the document in the Zoom chat. I'll put it in the Slack later too for anyone who wants to look over this. Let me make this a little bit bigger. Okay, So we've made this a habit now of every month. I just kind of go over what the latest ML news is, and so this month we're doing all the stuff from the previous month. So lots of models, lots of interesting things going on. Um, I'll start us off. One of the newest things that came out just a few days ago was Sora 2. So Sora 2 is this video generation model. So they made this nice release video showing basically you can ask it, make a video of this, and then it will go make a really, really nice, clean video of whatever you're trying to do. They released a corresponding app along with it, and so people have been playing with this a bunch. They call it Cameo, where basically you take a like test video of yourself and it records the audio too, and then you're able to like inject yourself into all these different videos and stuff. And so a bunch of my friends have been playing with this. And so you can actually go on the app, add your friends, and then add your friend's likeness. So you can make a video with two of you together or something like that. So this is something new that a lot of people have been playing with. Um, One of the previous things I showed in last month was VO3. So Google released a similar model, and people have actually been saying like Google's model is probably better in terms of video fidelity, but this one has a lot of nice like consumer things around it. Like OpenAI did a very good job of like making this app that you can play with it and makes it very fun versus the Google version. You're in the chat interface and you just say something and then it pops a video out and it's not as nice to play with. So Codex is a model that's been out for a few months now, and it's this OpenAI idea of like let's go write some code for you in the background. So you tell it make this change to my code base, and then it will like go through your GitHub and say, okay, here's a pull request saying how to make that specific change. So OpenAI made a new release of Codex, and some people have been very excited about it. The benchmark numbers are really not that impressive in my opinion. So if you look at the difference between the old one and the new one, the numbers look relatively minor, but the response on Twitter and everything has been very positive. They're saying like this is the best thing right now. So one of the things that has become more popular recently is ChatGPT is releasing something called Pulse, and it's sort of like your Jarvis assistant where you wake up in the morning and it tells you, oh, you have this meeting and you got this email and here's what's going on today and here's the news that's relevant to you, and it can basically make like a podcast and a feed for you that's just curated based on the things that you give it access to. So one of the things that I wanted to mention along with that is there was this team from Google that made Notebook LM, and Notebook LM, the whole idea was like you pass it an academic paper or some topic, and then it will just pop out a podcast for you. So they have two speakers and they're talking back and forth about whatever you gave it a document of. So then some of the people from the Notebook LM team left and then made this app. I don't know how you say it, Huxy. And it's basically the same thing as what ChatGPT Pulse is. And so the founders of this were a little bit salty on Twitter, saying basically like you copied all of our stuff. I actually downloaded this app and played with it. It's pretty neat. It can look at your calendar, it can look at your emails, and then it can pop out stuff, and you tell it what you're interested in. So if you say, "Hey, I'm interested in NVIDIA," it will make a like curated NVIDIA podcast for you, saying all of the new stuff that has come out. One of the other OpenAI things that got recently released was this GDP val. So basically what they did is they said, what like economic value do these models have? And so they did this test where they basically said, pull people from all of these different domains, have them write out like, what is my task that I'm trying to do? And then have them go complete the task. And then they also had their GPT-5 go try and complete that task as well. And then they had expert graders in all the different domains say, did I prefer the human professional or did I prefer the model's output? And some of the results they were getting are pretty crazy. So they're saying like Cloud Opus 4.1 is like nearly 50-50 with industry experts. So if you ask them to go do a task in like concierge service for real estate, then it might be able to do typically as good of a job as a human. So one of the things that they introduced along with this was the and automatic score. So the way they ran things was they had an actual expert review the output, but then they also trained a model on top of this saying, can we get a model to determine who had better output for a given task? So there's a model out there now essentially that can like be a work evaluator, like who did a better job on a given task. So one of the things that they also put out was a usage report for ChatGPT. So they're saying basically who's using ChatGPT and what are they using it for. So one of the interesting trends, there's a corresponding paper that goes along with it. One of the interesting trends was early on ChatGPT days, they were finding that men were picking it up much more quickly than women. Now they've seen that trend has basically closed. There's basically 50-50 usage between men and women. And then they were also digging into all of the different areas that people were using it for. So they're saying 11% programming and 30% self-help and all these different categories. So they cut it up in a bunch of different ways. So there's a lot of interesting information in there if you want to see what other people are using ChatGPT for. Lots and lots of OpenAI news this month. So they also put out a report basically saying, why do language models hallucinate? And so the thing that they were really pressing on is language models right now, they're trained to just try and make a guess at what the next token is all the time. And with that in mind, they're always just trying to say like, what's the most likely option? They don't have any like, there's positive if you get the correct token, but there's no like medium option if you just say, I don't know, I don't have access to that information. And so that was basically their point in this review, saying like, we need some in between where it's like positive if you get the right information, negative if you get the wrong information, but you can also pick a middle option saying like, I don't know. And that's a reasonable outcome as well. You need some like exit strategy if you actually don't have that answer. OpenAI made a big deal with SK Hynix. So this is one of the big coming trends is all of these companies are saying we need more compute. And so they're building data centers, all these different places. And so this is a huge deal for Samsung and SK Hynix because OpenAI is basically saying we need 9,000 wafers per month in the next year. And so that I did the ChatGPT math on that, and it's saying that each wafer is maybe like 2 or 3 terabytes of memory, and then they're doing 900,000 of those a month. So you can imagine that's like huge gobs of memory that they need produced because they want all these chips to have lots of memory along with them. One of the other OpenAI releases, so now they have this agentic commerce protocol. So they're trying to add this thing into the ChatGPT interface. So you can basically say like, oh, I want red shoes for running or something like that. And it will go actually recommend something for you. And then you can just click buy and then it will handle most of the transaction for you. So they have integrations with Etsy and Shopify. So anything that's on Etsy, Shopify, there's hundreds of thousands or millions of Shopify stores. So there's tons of stuff that it can recommend you and try to get you to buy. So this is something that I've seen Google and OpenAI both working on is like, how do we turn this into a commerce platform? How do I make it do more sophisticated things? And how do we make it secure in terms of payment and decisions and everything? So I mentioned the memory news, but also OpenAI is teaming up with Oracle and SoftBank, and they're putting $500 billion in trying to make all these massive data centers. So this is a very big deal. This is like on the scale of like we're trying to reach the moon with this level of compute. Like people are really making huge bets on these things. So moving on from OpenAI, one of the other cool models that came out that people are excited about is Claude Sonnet 4.5. So we've gone 3.5 and 4 and 4.5 very quickly. Like the progression has been only a matter of like 6 months or something like that. So this is another one where it's kind of an incremental boost. So if you look at the difference between Sonnet 4.5 and Sonnet 4, we've gained a couple percent on SWE-bench. Lots of big gains. One of the most exciting ones is this OS World boost. So this is basically the computer's ability to wander around web pages. So you tell it, I want you to go find the research blog page of OpenAI, and then it will go click around and say, okay, click this link, click that link, scroll down the page, and then find the information that you want. So this is a very significant boost. I think that's probably one of the highest gains on this list. People are pretty excited about it being able to use the computer a lot better. Along with that, so Claude made a deal with Microsoft, and this is kind of a big deal because Microsoft historically has been very linked with OpenAI. And so Microsoft actually chose Claude to power their Copilot, their like Office suite. And so along with this, they also added strong capabilities for file creation and file editing. So Claude built in this capability that now it can work with spreadsheets and text documents and whatever else, PDFs. And so I think that's probably a significant portion of what got them the win with Microsoft. They had the strongest capability in terms of like manipulating documents. So along with that previous point that I was talking about, the boost in the OS world, Claude released a Chrome extension. So with this Chrome extension, it can do that navigation like I was talking about. So they're trying to inject themselves in your browsers so they can basically say, okay, Claude, go scroll around, do some wandering in this specific browser, and then find the information that you want. This is not news. This is old, but one of the things I wanted to point out is one of these companies a long time ago, Adept AI. They had a whole bunch of top people from ex-Google, wherever, and they were doing this very similar concept where they were saying, like, we don't need a language model, we need an action model. And so the whole point was it was trying to do this sort of web and computer interaction stuff. And this company actually just blew up and failed. They're gone. But it's interesting that this concept has gotten like further advanced. So they weren't wrong. They were just early. They were before the capability was really there. It's kind of interesting that they had the idea, but they just ran out of money. They couldn't advance at the right rate. So moving on from Anthropic, there's some interesting things from Apple. So the Apple AirPods Pro 3. So the real AI portion of this is they have live translation built into the AirPods now. So they showed a cool demo where basically you put the AirPods in, someone else has AirPods in, and then it will just do live translation between the two languages that you guys are speaking. So you say, set mine to English, set yours to Spanish, and then it will go back and forth live while you guys are talking. So they have some cool videos showing what that can look like. Again, I wanted to point out, like, this is not necessarily new. It's just, it's in the like shiny Apple package now. So this is something that I've looked at in the past. This is called Time Kettle, and they have a bunch of interesting products around this. So they have the similar thing where you can put an earpod type thing in, and then it will translate between. But they also sell these packs where you can do this like mass interpreter thing, where it's like if we had a room where people had 20 different languages, this thing does the translation, and then everyone else has their AirPods in with whatever language they want it translated from English to Spanish, French, German, whatever. So Apple's probably going to do great with that, but it's a product that kind of already exists. So moving on to some Meta stuff, Meta released their new glasses, and these ones have a display in it, and you can also wear a wrist strap that will let you do some forms of navigation with it. So the Ray-Bans have been very popular because people were using them for recording video, but now it also has a display within it. So if you look in here, you wear the glasses and then you have a little heads-up display, and it can also show you certain things. So if you do a search, it might be able to show you a picture or do various things on top of it. So it's very impressive that they've been able to fit in a transparent screen inside of the glasses that doesn't like, totally block your view like a VR glasses. So they released their Vibes app, and so this is a little bit similar to the ChatGPT video generation thing, but it's basically like, let's make TikTok, but it's only AI generated video. So you just have like a pure AI slop feed that you can that you can go through. And so people have mixed feelings about this. Like you don't want like a total slop feed, but it's probably good that it's in a separate place than just getting injected into YouTube shorts and Instagram reels and everything else. So it's good that it's at least segregated in some way. One of the exciting models that they released is this code world model. So this code world model, a lot of the stuff, the models that people have been training, it's purely just like guess the next token. But then when you go to actually run code, it's not really knowledgeable about that. And so what they did with this code world model is they basically said predict what's going to happen with the code. So you have your interpreter and you say, okay, this is the code that it's going to run, and it will actually do the prediction of like what's going to happen when I run this code. And so they showed that it gave much better understanding of what's going on, because in the normal setting, it learns to write the most likely next code, but it doesn't exactly know what it's going to execute and what it's going to do. So they showed with only a 32 billion parameter model, they were able to get significantly better performance and better understanding of what the code was doing by trying to predict what's going to happen when I run this code. They also released this exciting new meta embed model. So in the previous talk, we were talking about RAG a little bit. So this is a model that you can use for something like RAG. You can basically say, I'm going to embed this document, I'm going to embed this image, and then I'm going to be able to do searches upon that. So I say, find me the document that has this certain chart, or something like that. And because this has multimodal understanding, it can go retrieve that and say, okay, you found figure 3 from this specific document. So one of the things that I want to point out, this flexible late interactions thing, this is interesting from the sense that in the past, what people were doing where they were basically saying, take an entire page or an entire document, and then I have an embedding for the whole thing. This later interaction thing, they're actually saying, make an embedding for every single token, every single image, every single element of this. So each of those has their own embedding. And then when you go do a lookup, you look across all of those tokens. So you have like a very granular look at the document instead of just like as a whole, what does this page represent? So there's pros to that. You get way better performance, but the downside of that is you end up with way more embedding. It ends up this massive thing. So very cool model, maybe not as practical because it does that technique of like, let's do an embedding of absolutely everything. Another interesting paper that came out is this deep think with confidence paper. So the big piece behind this is that people have figured out if I just do predictions with this same model over and over again with a little bit of randomness, and then I look like across 128 different predictions, what was the most common outcome, and then use that as the answer, you get better results than just doing a single prediction. But that's very inefficient. So it's limited in the sense of like you're doing 120 rollouts, you might not always need a full 128 for a given task. But the other thing is it's very naive. You're just saying like do 128 and then just find the agreement between them. And so this is a technique of basically combining them in a smarter way, saying basically like if this one has very low confidence, just cut it off, just quit the generation. So it saves you a lot of compute by kind of keeping the confidence of the model in mind. Moving on to Google Gemini, Google DeepMind. So they released this new Gemini robotics model. And so this is extended off of their very powerful language model. And so the whole goal here is we have this gap where you have the perception of the model. It can look at the world and understand, okay, there's a cup on the table. But then the gap is turning that into action. So the difficulty is I see that the cup is on the table. I know that I want to move the cup into the shelf or something like that. And then the difficult part is turning the action that you want to do into like actual fine-grained motor movements. So the difficulty is like I have a robot arm. You need to break that down into like I need to move this motor in this way and then this motor in that way. And so you have a whole sequence of things. So this is a very powerful model because they've fused the super strong perception of the Gemini model, and then they've figured out a way to make it so that it can actually control a robot, so it can understand what its various mechanical elements are, and then it can make decisions for you. And so one of the tricky parts with this is that they're trying to make it general to any robot. So you have different robots that have different motors, and this one has arms, and this one has motors and different pieces to it, and it needs to figure out, okay, what do I have access to, and how do I manipulate this world depending on the body that it has. So one of the major things that they did recently was this ICPC, and so this is a collegiate programming contest. And so the idea here is they give some extremely difficult programming problems, and then college students go and they try and compete and see who can solve the most problems in a certain amount of time. And so both OpenAI and Google competed in this, and they both got gold medals. So they basically, this was a big moment because both of these teams were able to basically say our model is smarter than the top college students now. So people have studied these problems and done the best that they can, and it turns out that both Gemini and ChatGPT-5 are able to solve more problems than even teams of humans on these very difficult tasks. So one of the things that's been popping up on Twitter is there's some Gemini 3 leaks. So some people get access to it early, and they've been saying, oh, it's very powerful, it's very good. So they're expecting that to release pretty soon. So we'll see what comes of Gemini 3. So moving on to thinking machines, this is a company that had a bunch of people from OpenAI. OpenAI had some drama. Some people got separated off, and so their CTO started this company, Thinking Machines. And so everyone's been kind of wondering, like, what are they doing, because they haven't released anything in a few months. So they released a few blog posts, and I wanted to touch on some of the stuff from there. So they released this Tinker project, and so the whole idea here is they wanted to kind of abstract the infrastructure pain away. So if you want to do a training run on a very big language model, then you have to have a huge compute cluster, and you need to be able to orchestrate it, and you need to handle when a GPU fails and all this other like painful stuff. And so they basically said, let's give an API to people, and we have figured out the infrastructure stuff. So if you want to train a Qwen 235B, we'll help you just do that. So you just write the training code, and then we'll get it to run. So some people are excited about this because a lot of the infrastructure like slows down research and prevents people from getting good results quickly. So some of the people that came off of OpenAI, this John Schulman guy, he's very known for some of his reinforcement learning stuff. And basically, he showed that LoRA is this technique of like doing low rank updates of your model. He showed that when you're doing reinforcement learning, you can do LoRA, which saves you a bunch of money and compute and memory. He was basically saying when you're doing reinforcement learning, you get very low rank updates. And so you can do LoRA and you lose 0% performance. So doing full fine tuning versus LoRA, it doesn't matter when you're doing reinforcement learning. So you can do tiny LoRA updates, and it's just as good as doing full rank, because when you're doing reinforcement learning, it's just giving you the basic signal of like positive, negative. So you only get one bit of information, so you can do low rank updates and get exactly the same result. Another major piece that they got was the non-determinism in LLM inference. So one of the major problems that people have had is even when you run exactly the same thing through an LLM, even with temperature 0, it won't get you exactly the same result. And so one of the people that this Thinking Machines got was this guy, Horace He, and he's like a super low level PyTorch guy. Everyone, when like something breaks on Twitter, they used to go to him because he was like the major PyTorch guy. And so he basically dug through and said, why exactly is this non-deterministic? We give it the same output, we give it exactly the same conditions, and it's giving us different results. And so he dug through and figured out, okay, what is the cause of this? Why are we getting non-deterministic results? And can we like freeze it in a certain way so that we do get deterministic results? And so he went through all the details and figured out, okay, if we're really smart about this, we can get exactly the same results, but it's at the cost of a whole lot of speed. So moving on, just one little NVIDIA piece, they released this Lyra model, and it's pretty interesting because you can give it a picture or a video, and then it will create a sort of 3D or 4D scene for you. So in this one, you just give it a picture, and then it's making like this interactive 3D scene that you can move through. So there's image to 3D, and then there's also video to 4D. So you can make a video and then turn it actually into this like 3D video where you can see this stuff is moving along, and you can also like pan and zoom around. So final section, one of the things that I like to do every month is go through the top Hugging Face models. So a lot of new ones this week. So this Hunyuan image is a new image generation model. So they're claiming that it's approaching the performance of like Gemini and all the image generation stuff that we've looked at recently. DeepSeek released a new version of their DeepSeek base model. So one of the major innovations here is they added a sparse attention mechanism. And so the benefit here isn't actually in performance in terms of like accuracy, it's performance in terms of memory usage and compute costs. So if you look at these, they swapped out this sparse attention mechanism, and a lot of these actually go down by a tiny percent, but the benefit is now you can say if I could fit 32K in my context, now I can fit 64 or 128 or something like that. This one from Tencent is pretty cool. So this is a model that basically can take some picture of a 3D object and then try to turn it into little parts. So it will say, separate out the crown, separate out the scepter, separate out the shirt, and then it can make a 3D model of all of these things individually. So you give it a complicated scene like this, and it says, here's all the different parts, and then you can kind of like extract out the little pieces that you want. So very, very cool implementation there. So one of the hot models is this GLM model. So this has been gaining a lot of steam recently. So this is their GLM 4.6. They've trained another big model in the series. People are very happy with this one. So one of the people from Klein is this coding agent that's similar to like Cursor and all the others. They did some benchmarks, and they basically said this model is so impressive, it's actually kind of meeting the performance of some of the top things. So if you compare it to like Claude and others, it's actually up there in terms of performance at performing edits of code and stuff like that. So people are very happy about that because now you have nearly closed source performance that you can deploy yourself. One of the top models was this Inclusion AI Ring 1T, 1 trillion parameter model. I don't honestly know that much about this one, but I think the interesting thing to me was I had never heard of this Inclusion AI, and they're training a 1 trillion parameter model. Like only a few months ago, that was like the only people who can do that is probably OpenAI and Anthropic, but it seems like other people are joining the game. So that's pretty interesting. ServiceNow released this thinker model. So again, I don't know too much about this, but it's interesting that ServiceNow is able to produce a model that they're claiming is pretty competitive with like DeepSeek R1 that everyone was excited about recently, and they're saying it's actually like shrunk 10x of that. So it's a pretty strong model. ServiceNow actually has some San Diego offices, so I don't know exactly where it came from, but it might be people in our area, which is cool. This Liquid AI released an audio model. So these have been coming pretty frequently. We see these audio models that they're trying to go basically, you talk to it and then it talks back. So it skips the whole step of like taking your audio, turning it into text, and then taking that text and turning it back into audio. So the big thing with that is just saving you a whole bunch of latency, because if you're trying to talk something, you don't want it to have to separate those steps out and then it takes 15 seconds to respond. You want it kind of live audio. So this Liquid AI has released a good model in that front. Similar to that, there's this Newphonic new TTS, air, and this is just focused on the text-to-speech side. So you type in some text, and then it will talk back with whatever you told it to say. One of the interesting things with this is they say that they have strong voice cloning performance. So you can basically say, like, say this thing in this specific voice. So you give it a little recording of yourself, and then we'll talk in your voice. So Open Data Lab, they released this document parsing model. So this is something that I used to work on. I used to do a lot of document processing stuff. So this is an exciting model because one of the major pitfalls of these document understanding things is actually you need very high resolution in order to read the text and get the tables out and everything. And a lot of the models that we were converting to there were like trained on little tiny 224 by 224 images. And so people have been getting better and better at how do we handle like 3K by 2K document. So this looks like an exciting model in terms of extracting tables and extracting text and doing all of that stuff. Quen has released a whole slew of different models. I've shown some of them in the past week. So this Quen 3 Omni is still very popular. This is a model that it's supposed to be able to do like all different modalities in terms of text and audio and image. So they're having it do all of these kind of interlaced together, and it's turned out to be a strong model. I saw this funny meme earlier. Basically, we moved from Quen 1 to 2.5, 3, and then it seemed like we were on 3, but then now Quen is releasing all of these side models, and so you have all of these side things where it's like, okay, we went to 3 and now we're back to 2.5 and 1 and everything else. IBM released this Granite Dockling model. So this is very similar to the previous one that I showed. This is a document conversion model. So basically, if you're trying to extract certain things out, you can extract from the whole page. You can say like, turn this image, turn it into text, or you can say like, draw a bounding box around a certain table, extract that specifically. So this Dockling model has been bouncing around for a while, but I think they released a new version, and so that's why it's up on the Hugging Face leaderboard again. ByteDance released this linked model. So this is personalized video generation. So this is in similar vein to the Sora 2 stuff. So basically, you give it some like image of yourself, and then it will be able to like generate a video with that person in like trying to keep their likeness together. Moondream is a very powerful VLM that's been released. So this is trying to take in text and audio, or text and images, and then be able to do some processing on top of this. I've seen a lot of talk about this on Twitter. And then last one, this Code World model that I talked about earlier. This is up on Hugging Face, so it showed up in the top list. And that's everything I've got.
All right, so many updates, but if there are one or two questions, we can take a couple questions.
So for the non-determinism paper out of Thinking, or blog post out of Thinking Machines, was he saying that we need to throw out or roll our own atomic operations to get rid of to get rid of the non-determinism problem?
Yeah, so it seems like the problem is actually the batching with other operations and things coming in out of order, basically. And so if it was like full precision addition and we just had unlimited precision, the order that we add things wouldn't matter. But because we have this lower precision and things can get rounded in slightly different ways depending on the order. So it's basically saying they went through and they made their own custom kernels for all of these things in order to force it to always follow a certain ordering. So yeah, I think that's the solution, is you have to do all this custom stuff in order to make it work.
Okay, cool.
I had a question on the same topic. So you mentioned that it's a balance between speed and determinism. So is the speed effect so bad that people will not adopt it, or what's the general feeling there is after this paper?
The speed I saw, I don't know if it's directly from the paper. I saw someone on Twitter say it was like a 60% drop in speed. So it seems like something where it's like if you really need determinism, you can do it. But if you're trying to actually use a model, you probably don't care enough. You're okay with a little bit of randomness.
Thank you.
Yeah.
All right. Thanks, Ryan. I think we'll
Yep.
wrap things here. And then I'll do a very quick computer vision presentation. All right. So we started going through this practical computer vision series that's online. And so this is the fifth in the series. This is workshop 5. And again, the approach here is each week there's notebooks, there's code that you can play with. And so it's less coming at it from the theoretical side, but instant gratification. There's a concept. You may not understand it super deeply, but at least you can play with it. And for those who kind of take the approach of, let me just modify the code, let me see if I can break this, what else can it do? It's a great way to be able to do things hands-on. So last month, we introduced convolutional neural networks. And so here it's just talking about, hey, if you're actually going to play with these and you want it to learn, there's a couple things in our tool belt to get these things to actually work and learn quickly. So jumping in, they say, here's an example of an old early CNN, and what you can see is that all the layers are just sequential. So the output from one layer is the input for the next layer. And if you think about like a chain is only as strong as its weakest link, okay? When you have these things all chained together, anything bad that happens in any one layer is going to be problematic for your performance. But the other thing to think about is we train these things with gradient descent and we do back propagation. And anything bad that happens to the gradient anywhere in the chain is going to be a problem. And so one of the problems they had was vanishing gradients, but there's other issues. And so it mentions that, hey, we're using these residual blocks. That's nothing that you necessarily need to do as a practitioner playing with this, other than any more recent model that you use is going to have these skip connections. And then that means that there's a path for data to flow through. And in theory, if you had something bad that happened in one layer, there's also a path around that layer. And so things are no longer so completely dependent on that one. So again, nothing really you need to do other than if you go to the library and you say, let me play with this small CNN. If it's a more recent one, then it's going to have skip connections. Okay. So then the next thing it talks about is normalizing the inputs. So in theory, a neural network can work with floating point numbers of any magnitude or whatever. But in practice, there's two phenomenon that we're dealing with.
Let me see if I can follow the slides a little bit here. But maybe not. So one problem is we have these activation functions, and the activation functions typically have two parts. The right-hand side looks just sort of like y equals x, that the output's unchanged, similar to that. And then the left side looks very different. In the good old ReLU, the output on the left is always 0, and the output on the right is exactly y equals x. But that decision point in ReLU happens at 0. So say if all your values were between 100 and 200, then there's not really a whole lot that can happen with that ReLU to add a nonlinearity in it. And so the weights of your parameters can move things closer, but it ends up just life's a lot easier if your data actually is kind of centered on 0 so that the activation function can do its thing. The other problem is, what if you had, this doesn't really happen in computer vision that much, but what if one pixel had values between 0 and 10, and the other pixel had values between 0 and 10 billion? Okay. Then what's going to happen is your values and your gradients are going to tend to be a lot larger on the input dimension that has just much larger values. And one of the things, if you've looked at the literature on optimizers on gradient descent, is that what you don't want is narrow, skinny valleys, okay, where the gradients are really large in one direction and really small and flat in the other. Because unless you're at exactly the valley floor, if you're on the valley floor, then you're going to go which direction's downhill on the valley floor. But if you're anywhere else, the steepest direction is going to be just in the valley direction. And so vanilla gradient descent zigzags back and forth, slowly making its way down the valley, but it's very inefficient. If you have something that instead of being skinny valley is more just like a circular bowl, then things go boom straight to the lowest point. And so I don't know if I'm following the slides, but basically you can see where you subtract the mean, you divide by the standard deviation, and just like with tabular data, you can scale your image data. And they have an example where if the model was trained under certain assumptions, expecting its data to look a certain way, then here's an input orange, and you can see it's like whatever, 85% confidence that it's an orange. But if you don't scale the pixels properly, then it's only, what does that number say? 57% confident. Okay. So the main takeaway is if you download a pre-trained model, you cannot just say, I'm going to download the model. You also need to know what are the expectations of the inputs for that model. So you have to know what scaling or what other things are they expecting you to do. Okay, then the next two topics have to do with regularization. So this is dropout and batch normalization. I don't think this is the best chart, so I'll use this one. So here is our validation or our test loss. And basically, what they're not showing is when you train this neural network on some images, the training loss goes down really nicely, goes towards 0. But if you just use a small vanilla CNN and you don't have any regularization on a reasonable size training set, let's say 10,000 images or something, your test loss, your validation loss plateaus and stays high. And that's because your model's overfitting. It's finding, imagine a 200 by 200 input image that's 40,000 pixels times 3 colors. It's 120,000 dimensional input. There's a lot of random correlations you can find. And I said 10,000 images, but you have 120,000 dimensions in your input. So it is really, really easy for the model to just basically say like, anytime there's a dog, the pixel that's 3 from the upper left corner is always blue. And that's just pure luck out of your 10,000 images. It has nothing to do with the real. But with that many dimensions, it's really, really easy. And so then you can see here by adding dropout, then it's able to regularize. So what is dropout? I didn't mention. So dropout is basically just turning off certain nodes randomly. So zeroing out the output of those. And imagine my example where you say, oh, all the dogs have a blue pixel in this one place. Well, if that node that's looking at the blue pixel gets turned off 20% of the time, then it's not going to be able to use that as a crutch. And so that's how dropout sort of prevents you from finding these tiny little things. Your model can still overfit, but it's going to have to overfit on more complex random correlations than just super cheating and looking at things like 1 pixel or something like that. Yeah, and so dropout is used a ton in deep learning. I think you'll sometimes see some models they turn it off, but LLMs, computer vision models, most of them have some level of dropout that is used. And then here's this visualization. You can see we have an image. They ran it through a CNN filter, and so the orange now looks a certain way. They apply ReLU activation function. So now it's sort of zeroed out certain things. So that's why all of a sudden now you see there's some dark things. But you throw dropout in the mix, and then you just have a bunch of randomness that's been added. So it's essentially adding noise. It's not part of today's lesson, we do add noise to our images, but that noise is only added once at the very beginning, the input to the model. When you have dropout in your various layers, you're adding noise at each layer in between at each stage. And so that can be a very advantageous form of heavier regularization. Another important tool in the deep learning toolbox is batch normalization. And the idea is basically you find sort of the again, the mean, the center, and the standard deviation, the distribution of your data. And I kind of find this visualization kind of helpful. So imagine that your unnormalized data looks like the red dots, and then batch norm basically says, I'm going to move all the dots to be centered on 0, and I'm going to have the dispersion, the variance of it be within a certain predictable range. Okay. So if your data was super tight, then it's actually going to spread it out. And if your data is super spread out, then it's going to bring it in tighter. But either way, it's a very predictable range. And then this works well with the way that we initialize our parameters and again, with the activation functions we use. I don't know, Ryan, if you can help me here. I'm not familiar with batch norms used a lot in models, but I don't know about just like basic computer vision models like CNNs or whatever. Do you know?
Yeah, it's very common. I think a lot of people have moved to layer norm and other sorts of stuff, but batch norm is still like
Okay.
It's in your typical block. If you say I have CNN max pool batch norm, that's
there is a norm in there. Okay,
Yeah.
then I stand corrected. Yes. So and again, the idea is that where you can, the thing I talked about before, you can normalize your pixel values. That's only happening once at the input. But if you have a deep model, a ResNet 50, a ResNet, whatever it is, 151, now you're talking about 50, 100 layers. You did one normalization, but values can sort of drift and grow or shrink. This is happening, and it's sort of keeping in between, just like I talked about with the dropout. You're not doing it once, you're doing it between every set of layers. You're keeping things in a zone. And this is super important for learning to happen. I think if you could just sort of like magically keep your data in the right zone, you don't really need this for inference. But what you do need is this in order to have your model train fast. So if you don't want to wait 10 years for your model to train, then these are the tricks that then keep things in that zone near the kink in your activation function so that you can have really interesting things happening. We want nonlinear patterns for learning so that we can have our, highly complex output function. If you have all linear activity, then you can only have a very linear looking output. And so assuming your input, like cats and dog images, is not just linearly separable, you want that nonlinear behavior. So there's a few more images, and then I guess, yeah, so that's the end on this section. And so then one more final thing where they talk about the skip connections in a little bit more detail. Again, you don't typically have to worry about building these, just know that they exist there. And so here, there's a slide talking about the vanishing gradient. And again, as you pass through layer after layer after layer after layer, if you say, you know, I'm making a small change to the weights, those numbers multiply. And so imagine if you just had 50 layers and you know, divided it by 10 every layer, all of a sudden you have now gotten a very, very, very tiny number, you know, 10 to the minus 50, right? So underflow is a problem, and that's what this skip connection provides. The other intuition that I like is the idea of again, if you have that older architecture we saw, it's like a chain, okay? And you take your input, and then so imagine that you're building a car, and so then the first layer, basically, you get this mountain of just raw material metal, and you have to do something with this mountain of raw material metal, and then you have to pass it to the next guy, okay? And then they have to work with that and whatever. And if anybody messes up, it's pretty much fatal for this car. With the skip connections, it's more like you have an assembly line. The skip connections are the assembly line, and the car is just moving past. And your job is to modify it a little bit. So my job might just be put the front left wheel on the car, and somebody else's job is put the back left wheel on the car, and so on and so forth. Add the door handle, whatever. Okay, and so now the job isn't sort of like so completely dependent on passing the entire car from person to person, but rather you can think of the layers instead of having to completely own what's happening with the information. Their job is just to tweak, to do that minor change, so whether it's a car assembly line or like an assembly line of sculptors, and each is just doing a tiny little bit of chiseling or whatever, and at the end of the day you get your final statue. So for me, that's kind of an intuition. And then there's this famous paper from a bazillion years ago, visualizing the lost landscape of neural nets. I think it's like a 10-year-old paper or whatever, but they came up with a nice technique to say it's highly dimensional, but what's a way in which I can sort of pick random directions and do something useful? And so if you see an old-fashioned VGG style CNN and you say, what's the lowest loss for classifying dogs and cats? You want the lowest loss down here, and there is a configuration of the parameters that will give you a very good dog versus cat classifier. But gradient descent is going to have a hard time finding that minimum because the landscape is so completely complex. And then when they looked at a ResNet and they visualized this, it was like, oh my God, this is just so much smoother and simpler. And so you can see why gradient descent can much more rapidly find the right direction and then just go zoom down this bowl and more quickly get you. So nobody's saying that it's impossible to train a CNN without skip connections. It's just, it might be a lot harder, it might be a lot slower, and that's why everybody uses them. Okay, so there are notebooks that are in the repo, and you can play with these guys. And that's a good way to get really hands-on experience, but this is just a little bit of the background. As we go through the hands-on machine learning book, so next week, it's dimensionality reduction. So a month from now, when we do workshop 6, basically we will have caught up because we're going to start talking about neural networks and deep learning in the Hummel book, and then basically we will be talking about CNNs approximately a month from now. And so that's where these two will kind of come together. So if you want a deeper understanding of some of the theory, we're going to get that in the Hummel book. And then this will allow us to continue. And there's some cool things in this series that we're not going to see in the Hummel book. In some of the later workshops, we get to do things like visualize activations and see like which part of the image a model is focusing on in order to make its decision. Is this a dog or a cat? And it's going to talk about some other, complex things like diffusion models and whatnot. So I think the two will kind of pair and complement each other. All right, we're over time, but any questions? I know I went through this pretty fast. Any questions before we wrap up for today? Yeah, can you?
Yeah, so I kind of understand, like, I'm wondering if you have maybe a more sort of like mathematical intuition of why the gradient of the skip connections looks much smoother. It kind of it makes sense, but I can't articulate why it makes sense.
An intuition why the gradients are smoother. I have maybe two comments. The one big one for me is if you have a ResNet, but you also have dropout, okay, then it turns out that if to use my car analogy, there's not just one person who puts the front left wheel on the car. There's like the first guy whose job is to put the front left wheel in the car. And then there's the second guy who's like, if I don't see a front left wheel, I'll do that. Okay. Because if there's dropout, right, on the first one, somebody has to put the front left wheel. Okay. And so one of the things that ends up happening in these deep neural networks is we see there are distributed representations and there are redundant representations. So you can think of, I don't know if this is a good analogy, but there is an intuition around the data that's going through a neural network as sort of like this, when you have light and you have like an interference pattern, you get constructive interference where things like build up, and then you get, what's the opposite of that one? Destructive interference. Okay. And so basically, if you have a certain pattern that you're looking for, like let's say I'm looking for something that I think looks like an eye, okay, you could have your sort of, my one calculation is I see a vertical line on the left and a vertical line on the right, and a horizontal line on the top, and I put all this together and I think this looks like an eye, okay? But if you imagine instead that there's like a dozen different patterns that all constructively interfere and agree that if you see any of these kinds of patterns, then they all sort of scream yes. And then anything else, you might get out of the 12, one yes, but you get 11 no's, then they'll destructively interfere and you won't. Okay. So in that sense, then I'm totally making this up. But if there are these 12 things, they're each contributing something smaller, and there's no life or death decision based on this one particular input. Okay. So it's a little bit more like, a bunch of sculptures slowly chipping away. And if you're doing that, then your gradients are all really small because you're not like the one guy responsible for making the life or death decision. Does the image we're looking at have eyes? No? Okay, maybe it's a rose. Yes, maybe it's a dog. Okay. I don't know if that's 100% true. I don't know if that's helpful, but that's kind of like my intuition. Did you want to add to that, Ryan? Yeah, go for it.
Can you scroll up to where you had the batch normalization plot where you showed? So like the first one when you had the landscape. Yeah. So just looking at that one, imagine this is with and without the skip connections. But then if you go up to the batch norm one,
I don't remember how far back.
that yeah. So imagine your space is stretched in all these different ways, and so applying batch norm is one way. At like each level, you might have different alignment, and it's stretching across a different mean, a different standard deviation. And so batch norm is one trick to say constrain it to always be in this same spot. So one of the ways that I think about the lower plot where you have the like rocky landscape is that saying each of these has been normalized in a way and stretching at a different spot. And so batch norm helps on one level, and then the skip connections helps on another level, saying like I can push this through all the layers and it's got similar mean and standard deviation, and it's going to pass the signal through properly. That's my like vague mathematical interpretation of it.
So geometrically speaking, would you say it's kind of like if you have multiple different decisions, you're kind of layering them on top of each other, all in this purple section down here, instead of like, well, maybe I need to make one decision about this part of the reds, and I need to make some other decision, and you kind of line them all up, then it's easier to do group decisions.
So if you go down to the loss landscape one, the way that I imagine it is like you see one of those big peaks. That's somewhere where it's not in alignment between the layers, basically.
Yeah.
So somewhere has a mean that's very shifted, very stretched in one way. So if you change the value, it's changing the movement a lot. But if you kind of line them all up to be the same, then you hope that they're kind of like their optima is aligned.
Yeah. So said another way, if we're looking for the lowest spot, if you took this kind of low spot and you took this kind of low spot and you took that kind of low spot and you shifted them all so they're all right here at 0, 0, then they all contribute towards, moving in the same direction, rather than having to sort of optimize those individually and look for the right combination. And this down here is the magic combination. But yeah, I think it's a cool geometric intuition. Follow up?
Just kind of as a follow-up, thank you for that, by the way. That actually put it like, some of those peaks are, as you mentioned, having to do with like specific layers, and the ResNet or the skip connection aspect of it, sort of normalizes that almost between the layers of like, is that actually like a signal, through something like that. What I'm kind of curious about is I've heard of that ResNet sort of architecture being used in other formats or other applications beyond computer vision. Is that
Oh yeah,
correct?
LLMs, they're all based on residual architectures. I think pretty much everything is at this point.
Really? Oh, okay. Well, I guess I was kind of wondering, like, at what point during training would you maybe like look at your model and be like, hey, this could use like a ResNet layer or something.
So let me just try this as a thought experiment. I just thought of this on the fly. I don't know if this is going to work or whatever. Okay. You know that game where it's like you're given 3 or 4 numbers and you have to like choose a way to like add, multiply, divide them or whatever so that the answer is 42 or something like that or whatever, right? So in that game, you're doing a bunch of sequential operations. So I'm giving you like 4 number inputs, and then you get to decide, like I have to, do something with these or whatever. Okay. But like imagine instead that you have this assembly line and you just have this number sitting on there. Okay. And your job is to get it to 42. It's like, okay, well, is the number bigger or smaller than 42? If it's smaller, I'm going to add something to it. If it's bigger, I'm going to subtract something from it. It doesn't take a lot of intelligence to figure out how to make the number closer to 42. Okay. But if you just say like, well, the layer after me is potentially multiplying by 2, I don't know what's going to happen if I modify this thing and then something completely different happens later when it gets multiplied. But if I know that it's just on this conveyor belt and every layer is just making a small tweak to it, then I kind of don't even need to worry about what's happening after me. It's going to be small enough that then, I make a slight change to the way I'm doing what I do. Everybody else after me can adjust to that slowly, through gradient descent. But you it's much harder to catastrophically break what's happening just because one layer decided to update its weights. Whereas if you have this completely sequential thing, right? And you know, uh, again, I don't know, but like if the first thing you did when you're given two numbers is you subtract the first two numbers and you get a really small number, and then you're going to multiply that by the third number, which is 25, right? You tweak that first operation and then you decide, instead you're going to do something different. And let's say, you add the two numbers. You add the two numbers, you multiply 25, and all of a sudden you're at 5,000. You're nowhere near 42. But with that assembly line, like you're sort of less dependent. Is that a helpful intuition?
Yeah, sort of like reducing the sensitivity of any one operation by yeah, that makes a lot of sense. Appreciate it.
I'll share my screen for a second just to show. There's kind of two variants of this, I would say. So the one that Ted was talking about, so this is an example of a ResNet, and I know this is blurry, but you can at least see the arrow connecting these things. So imagine you take some input, you do some convolutions on it, and then you do some more convolutions on it, and you have this skip connection that's saying, okay, skip these two layers, just pass the signal through directly. So that's like the simplest outcome, is just saying skip over some layers, just pass the signal directly above them. And then the other case, there's this DenseNet model, and the idea here is basically don't just skip one layer, pass the signal to every layer after. So imagine you have this input and then you process it in some way and you pass that to the next block, to the block after, to the block after, to the block after. And then this next layer is receiving the direct signal and the one from before. So by the time you get all the way to the end, you're receiving this signal from this yellow block here, but that yellow block actually received all of the signal from the previous layers, and it's also receiving the skip connection all the way from the beginning. So this is like hyper connected. It's like every layer has received the original signal plus all of the processings of the previous signals. And so this model showed to be very, very performant for its time, but you're also just passing a lot of signal all over the place, so it ends up being very memory hungry because you need copies of this thing to get passed to every different place. So the residual skip connections are very useful, but the variant that you more commonly see is something like this, where it's simpler. You just say, okay, skip over one layer or two layers or a block or something like that. And typically you don't have to go as crazy as the DenseNet setup. You can just say, okay, pass it along a little bit, and then it helps you a lot, actually.
I love it, Ryan. Yeah. So if it helps, think that if you had a 20-layer model, the first layer is directly talking to all 19 layers. And then the next layer is directly talking to all 18 subsequent layers. And then those layers, they can choose. They can ignore inputs from certain layers, right? If they want, you can say, I'm only going to pay attention to the guy right before me. Or if you want, you can pay attention to people, further back. The last layer is going to have 19 different inputs coming at it, and it can just, choose, right? That's like the fully most performant form of skip connections, but it's expensive. And so in the end, we figured out how can we tweak things with only just one skip connection that passes along, and that's like good enough. The other thing, which I think maybe obvious, but I wanted to just share this because this is a transformer block for an LLM, decoder LLM, so GPT style. So we have the attention layer in the orange and the feed forward in the blue. And here you see these skip connections going around the side. Okay. And that's the way most people draw these things. It's convenient, but I actually find that it doesn't help the intuition. So the better way to draw it, if you want to understand the concept of residual connections, is you draw the residual as the straight line and you draw the computation units as just hanging off of this. So this is my assembly line. This is my sculptors just making small tweaks. And then if you, I think I have another one where there's multiple token positions. And then once you add layers, then you're stacking them up. But then you can see there's this information superhighway that goes straight through. And so in theory, this model, if all of your computation units originally output zeros or very tiny numbers, then basically what happens is you have this nice, clean, understandable path. In the case of an LLM, that we embed it and then we unembed it. And so if you zeroed out all of your original layers, then basically what you would get left with is a bigram model where you basically just predict the next token based on the previous word and no other computation. And so that's in fact the intuition, is that in a terrible transformer, your baseline performance is it won't do any worse than a bigram model. And then ultimately you have understanding that happens in these layers and you build it up. But I always prefer just this this thinking of drawing this as the straight line instead of the way they usually do it. It's not obvious the way the residual connections when you draw it this way versus if you draw it this way.
Yeah, thanks so much for the intuition. Super helpful. I actually have a question around batch norm and layer norm since we talked about it earlier a bit. So in terms of batch norm, I guess it's sensitive to like your batch size. Like as far as I remember, batch norm is just normalizing your single batch. So if you have like data that is very like non-uniform and has like different means, your batch norm can actually like converge to different normalization parameters. So it's like, I guess it's pretty sensitive to that. Like, so how do you deal with like batch size in a sense? And when would be the appropriate time to use layer norm instead?
So it's taken me a long time to wrap my head around batch norm and layer norm, and I tend, if more than 5 minutes has elapsed, to forget. Okay, but the name batch norm is actually a bad name. It's a misleading name. Okay, because I thought that batch norm had something to do with batches, and it actually has nothing to do with batches. So somebody's going to have to correct me so I get this right. But basically, batch norm and layer norm are doing the same general idea of centering things. It's just whether it operates on the whether it operates on it's which dimension. So you have this multi-dimensional tensor, and so one of them is operating. Yeah, Ryan, please. So yeah. Because if you have like a length 512 vector, one of them is operating on the 512 elements, and the other one is operating on the other. So in that sense, okay, so here we have so we are learning statistics from batches from instances. Okay. But those what we learn is learned over time. So eventually you train long enough, you're really just talking about the statistics of your entire training set. So the idea of batch kind of goes away when you run enough steps. Okay. it is originally using batches, but in the intuition isn't that it's a batch-based phenomenon because you're not doing it per batch, you're aggregating overall time across your entire data set. So it's really just saying, I've learned this, and then if you look at the blue thing, then each channel, if I have, I don't remember what I said before, if I have a 256 dimensional vector, each of those 256 is getting centered. Okay. With layer norm, then what I'm doing is I'm normalizing across my 256. So I'm saying I want the 256 to, as a group, be, and so I guess in theory, if you do batch norm different dimensions of your 256 could be doing some kind of interesting different things depending on your data patterns. But when you do layer norm, it's basically impossible because you are centering based on those 256 values. You can't ever have one that's just consistently somehow super wacky different. Because you're essentially saying so my intuition is with layer norm, you're sort of much more directly enforcing that my 256 floating point values are going to be zero centered or whatever I decide. There could be an offset, a bias, but they're going to conform to whatever my normalization rules are. And with batch norm, you're more saying like, in expectation, all of my values are being forced to be centered, but I'm not directly, since I'm operating on each one of the 256 separately, it's possible for there to be some discrepancies in how they're being centered.
So just if I rephrase that a bit, like batch norm is pretty much just like like normalizing one feature at a time, and layer norm would be like normalizing across all the features at the same time.
Yes.
Right.
Yes.
Right. Thank you.
And thanks for the assist, Ryan, because yeah, I like kind of know it, and like we look at this diagram, and then 5 minutes from now, I won't be able to explain it either. So.
I think so. Going back to the previous diagrams that Ted was showing, where you like smooth the bowl out, you have this distribution that's shifted and stretched in a certain way. This is trying to correct for that. So ideally, you want everything zero mean, 1 standard deviation. But the difficulty with that, so you can do that easily on the inputs. So you know all of your inputs have a certain value, normalize them, mean, standard deviation. You can do that once and it's solved. But then the next layers, they're shifting as you're training things. So some values going up, some values going down. So you could say basically pass all of your inputs through, and then at this layer, how do I need to shift it so the entire thing is mean 0, standard deviation 1? But it's very expensive to basically say, I have to do this through the entire thing for my entire data set in order to find exactly the right mean and standard deviation shift. And so you kind of have to approximate that in some way, basically saying, as I'm doing batches, kind of accumulate a mean and standard deviation to figure out what the shift is. But it's changing the whole time. Every time you're doing a training step, you're actually moving and shifting these things. So it's kind of a difficult thing to do.
Yeah. So I think from looking at it sort of from like an anthropological perspective, you can imagine some ML engineer who says like, I built this network, and then after the first layer, my data is no longer normalized. I normalized my inputs, and now it's no longer normalized. So what I could do is I can pass my entire training set through this layer and see what the mean and standard deviation are, and then I'll know how to normalize this, and I'll be able to do my one gradient descent, update or whatever. But passing your entire data set through the entire thing just to get that normalization constants to do that every step is an insanely ridiculously expensive thing. So then the ML engineer's like, what if I don't do the whole data set, but I just get my approximate statistics from the batch, and then I aggregate that over time so that eventually it should converge to whatever my whole data set statistics are. So that's my idea, like anthropologically thinking of like, how did somebody come up with this? It's because they wanted to do what Ryan said, and then they're like, that would be ridiculous, so let me do this instead. And then that lasted a really long time, and I don't know who came up with like, let's try doing, you know, layer norm in the other dimension. But then and then yeah, that one of the other things on Ryan's diagram was instance, and in that case you're like screw the data distribution. I'm just simply saying my 256 values, I'm slamming them into this 0-1 range, regardless of what everybody else is doing, which is a little weird because then you might actually be normalizing every instance differently. So that's why I don't think you see instance norm typically, but you do see these other two, and somehow layer norm empirically has worked better, and so we see the transition from batch norm to layer norm, and then the next thing we saw, the next generational leap, was we went from layer norm to RMS norm, which has to do with, I believe, no longer centering it on 0, which was not intuitive at first, but in the end, it allows it, I think, to be a little bit more expressive because you're not forcing it to 0. And then, at least for LLMs, it turns out that RMS norm seems to work better without the centering. So is it intuitive to have normalization after every layer? Yes, I feel like this violates all of the theoretical guarantees of the convergence of gradient descent because you're modifying the data. But in practice, it seems like it works, and whatever distortion the normalization is doing, the layers compensate for that. So if you think of it as just sort of like a small bias offset, then it was like, well, okay, then the layer can just know that if you're going to add 2, and I really care, I'm going to subtract 2, and I'm going to undo whatever you did to me. And if it's multiplying by 3, then I can say like, well, I'll just lower all my weights by 1/3 if I really, really badly want to undo what you're doing. And so it seems like yeah, that's the great cheat sheet or whatever. And then what was it, the Olmo LLM, they were like, because there's people who do normalization before the layer, and there are people who do it after the layer. So the original attention to all you need paper, you see it done after post norm, and then everyone gravitated towards pre norm. And the Olmo folks were like, you know, there's a reason, if you think about it, why it's like good to normalize your inputs before you do a whole bunch of calculation. But then it's also a good thing to normalize after, because then what you're writing to the residual stream is also, you know, bounded. And so they're like, why choose? We're going to normalize before and after, which is kind of nuts. But it actually worked pretty well. It hasn't been adopted, but yeah. So like you can not only normalize each layer, theoretically, you could normalize twice before and after each layer. That's right. Yeah, it's helping the layer converge faster, and then ultimately the idea is that it can calculate whatever it wants. What we're trying to, in practice, do is accelerate training time, and then the quality of the model, in theory, should be roughly similar because, again, the model can compensate for the layers if it really wanted to. All right, awesome. Thanks, guys. We're going to wrap things up here. Thanks for everyone who stuck with us. I apologize if you had plans and we kept you past, and now you're going to be late for your sister's birthday party or something like that. But thanks. Next week, we're back with the hands-on machine learning, and dimensionality reduction is the topic for that chapter. All right. Thanks, everyone. Bye.